The presentation topic is selective structure-based virtual screening for full and partial agonists of beta-2 adrenergic receptor. Presented by Mu'min Ahmed, Steve Nabil, Hisham Said, Ramar Rifai, and Mali Tawfiq. The aim of current study is to challenge the beta-2 adrenergic receptor structure for its ability to selectively retrieve partial full agonists using structure-based virtual screening method. Methodology: customization of beta-2 adrenergic receptors crystal structure to accommodate full and partial agonists. We have performed automated docking stimulation of inverse agonists, neutral agonists, partial agonists, and full agonists in the crystal structure of beta-2 adrenergic receptors, and observed the effect of full agonists such as isoprotrinol to satisfy excitement. The agent combined with the requirement of the first step. We then customize the crystal structure of adrenergic beta-2R receptor, then reflect the second agonist binding step, altering the rotational isomer state of S5.43 and S5.46 allows the hydroxyl oxygen of these residues to enter the binding chamber, almost within the hydrogen bond distance from the hydroxy group of catechol and beta-hydroxy oxygen. Docking beta-2 adrenergic receptors ligand to inactive and early activated receptor structures. For elevating the performance of the ligand-based and receptor-based virtual screens, a database was prepared consisting of 13 known beta-2 adrenergic receptor antagonists versus inverse agonists. Ligand-based and receptor-based screening. The factor screening method based on 2D and 3D ligands are shown here, consistent with previous reports, which are very competitive when screening GPCR ligands are expected. Reverse agonists and antagonists with high ROC values as well as randomly selected enrichment can be selectively searched using the inverse agonist S-carbazolinidol as a reference. When only fragments that are broken are common to both ligands, ROCS effect, while ACFP/4 and IFP scores don't. The latter method still ranks among the top scores among the butoxamine. Computational methods: automated docking based virtual screening. The ligand database is automatically docked in the original beta-2 adrenergic receptor crystal structure and the custom beta-2 adrenergic receptor structure using Surflex standard parameters. Ligand database preparation. 980 drug-like decoys were carefully selected to cover a range of properties similar to real actives, but structurally different from any known actives. The beta-2 adrenergic receptor ligand was manually depicted in ACEs draw. Interaction fingerprint scoring. The standard IFB scoring parameters and Tanimoto coefficient measure the similarity between IFB and reference molecules to form figure A. IFB is defined using 7 different interaction types: negatively charged, positive charge, hydrogen bond acceptor, hydrogen bond donor, aromatic face-to-face, and hydrophobic interaction as mentioned in figure B. Results. Table 1 recovering chemically similar decoy of known beta-2 adrenergic receptor ligands in large chemical database, but not distinguishing between full and partial agonists of inverse agonists and neutral agonists. 200% false positive in terms of ROC values. Rates are not at least as good as those previous reported in beta-2 adrenergic receptor based on similar structure in virtual screening experiment and are usually better. As expected, inverse agonists of S-carbazolinidol can be used as reference of selectivity. Search for inverse agonists and antagonists with high ROC values as well as random selected enrichment. Result value. First result, we have conformational change in the TM helix such as binding or rigid body motion, which may be ligand dependent and difficult to predict. Based on the indirect biochemical methods, the structural change is smaller than the previously proposed structural change. The second one, consistent with recent comparative evaluation of different virtual screening method, confirming that IFB scores performed relatively well in virus stent hopping scenarios. Final result, there was a successful outcome, better than before, but didn't distinguish between partial and full agonists as mentioned in table 1. According to table 1, figure 5, 200% false positive rate of random backing enrichment. Criticism. There is no criticism in this article. Thank you.